In humans, there was chemical castration. Here, there was actual castration. We use guinea pigs in particular because they make the human form of amyloid. And you saw a marked rise of amyloid, not only in the blood, but we were able to measure it in the brain.
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. My name is Jesse Lawler. I am your host, and this is the 192nd episode of this podcast dedicated to anything and everything that you can do to best help the workings of your own brain, keeping it in there for the long haul, but being able to take advantage of all the good things that the future will have in store does face us with some biological obligations, and high among those, maybe close to the top of the list as far as brain maintenance is concerned, avoiding Alzheimer's. Alzheimer's is probably right up there with cancer as one of the most feared things that can happen to a person. In this episode, we're going to be talking about something that we don't oftentimes think of in the same context as Alzheimer's, the famous in its own right hormone, testosterone. Turns out that optimal levels of testosterone might do a lot to stave off Alzheimer's. We'll find out the whys and hows from one of the major who's in the study of Alzheimer's, Dr. Ralph Martens. If you hang around until the very end of the episode, I'm going to tell you about a very specific food, one that's not hard to work into your diet. There is new research showing its effectiveness in staving off Alzheimer's. That will be in the Ruthless Listener Retention gimmick. But for right now, let's kick things off, as usual, with This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
So the phrase that first comes to mind when most people think about evolution is survival of the fittest, which kind of implies in its cartoon version at least a single individual versus everybody and everything else, that the fittest is some particular incarnation, some particular phenotype that is just so darn well adapted to its environment that nobody else can mess with it. But when you start looking at social animals, it very quickly becomes clear that even though individual animals may live and die independent of the others in their group, at some level there are selection pressures that are operating on the group rather than purely on an individual. If you have a queen bee without worker bees, that's not much good. If you have a worker bees with no queen, that beehive's in some trouble too. So in some cases, having some natural variation, sort of a spectrum of traits within members of a group of animals, can be to all the animals' collective advantage. This can be really interesting when you're looking at psychological profiles among humans and how to some extent those are genetically determined and, risk takers within the population versus extremely conservative people and the spectrum of everybody else in between. And researcher David Sampson from the University of Toronto recently got curious about human chronotypes, where a person's circadian rhythms tend to stabilize, if variation in human chronotypes might itself have an adaptive advantage, and could we prove it? 50 years ago, a psychologist named Frederick Snyder speculated that animals that live in groups draw benefits from having animals with a variety of chronotypes, so some are awake at night while others are asleep. There's always somebody awake to sound an alarm if trouble shows up. It sounds reasonable, but it hadn't really been tested out in humans. So Sampson took off from Toronto and headed to Tanzania, where he stayed for a few months with tribes that lived out in the African bush named the Hadza. He recruited 33 adults from 2 nearby groups and asked them to wear motion sensors on their wrists so that he could monitor their sleep. He did this for 20 days, keeping careful track of who was asleep when, how much overlap there was, and how this varied with age, gender, all that stuff. According to Sampson, it turned out that it was extremely rare for there to be synchronous sleep. The positions of various age groups on the bell curves will not be a surprise. The young people tended to stay up later. The old folks tended to get up very early compared to everybody else. And during the night times, there was a median average of 8 individuals awake at any one time. In the 20-day period of the study, there were a total of only 18 minutes where everybody was asleep, which is to say 99.8% of the time, at least one person was up. According to Sampson, who's giving a hat tip to an old theory called the grandmother hypothesis, which basically says that even though grandmothers are no longer of breeding age, they can still be advocates on behalf of their own genes by helping their own children to take care of the grandchildren. Sampson is calling his age-related variants of chronotypes the poorly sleeping grandparent hypothesis, saying, having a mixed age demographic increases the sentinel-like behavior within the group. So the next time you hear one of your parents or grandparents making coffee at 4:50 in the morning, realize that all that banging around in the kitchen, they might just be doing their biological job.
Smart Drug Smarts, the podcast so smart, we have smart in our title, twice.
Picked up a couple of 5-star reviews on iTunes this week. Listener Froz from the USA says, "You never know what it'll be about, but it's safe to say it will be interesting and will help you make the most out of your body and brain." And Tight Logics, also from the USA, says, "I don't usually take the time to do reviews, but the amount of valuable information this show has provided me with, I felt the need to give back. Thank you for consistently delivering timely and accurate information and helping people to navigate the smart drug industry." Well, thank thanks very much to both of you. Thanks to everybody that's left reviews and to everybody that has poked, jostled, threatened, blackmailed, or otherwise encouraged anybody else to listen to Smart Drug Smarts. Very much appreciate your helping to spread the word. A few people have reached out recently wondering, okay, the water fast is done for this year. Is there anything else weird coming up next? To which the answer is kind of yes, although I don't think that this will probably be a group participation thing. I do have a rather elaborate N=1 experiment planned. This is a visual thing, and I'm probably going to kick it off right after the solar eclipse that's going to be happening in about 2 weeks here. I've never seen a full solar eclipse, and I'm pretty excited about that. But right after that, I think a new experiment coming up. I will certainly talk about that in an upcoming newsletter edition, Smart Drug Smarts Brain Breakfast newsletter. You can sign up for that at smartdrugsmarts.com/newsletter. Another email newsletter you almost certainly want to be on, something that comes out more frequently than the Brain Breakfast, quick to the point, making you a quick offer and then letting you be on your way, is the Vitamunk launch list. Vitamunk, along with Axon Labs, are the two supplement sponsors of Smart Drug Smarts. And Vitamunk's launch list is a way of finding out about screaming deals that they make when they first offer something to the public, something where they're just trying to jack up the number of products shipped. They're not trying to make a buck on it, and the prices reflect that. It is really pretty ridiculous. Sign up for that if you want to see what I'm talking about at smartdrugsmarts.com/launch. And not to be forgotten, near and dear to my heart, my bloodstream, and crossing my blood-brain barrier, as a matter of fact, I've got a couple of Nexus in my system right now. Nexus is the aniracetam-based stack over at Axon Labs. You can find that on the web at axonlabs.io. Pop on by, pay a visit, and if you find yourself wanting to get some exercise after this interview you're about to hear, which you very well might, do not forget about Mitogen, Axon Labs' mitochondrial support stack. General energy support there for your brain and body. Mitochondria are everywhere, and Mitogen, among other things, even promotes the production of more mitochondria within your cells. Well worth checking out if you haven't done so yet. You can find both Nexus and Mitogen at axonlabs.io.
Smart Drug Smarts.
So true to form in this podcast, as I've mentioned before, through no fault of my own, no real intention, we seem to have a special affinity for booking neuroscientists from Australia. Oz has been very, very well represented as far as the head count of interviewees. That's not by design, but I can't quite complain about it either because there's been some amazing interviews within that group. This is going to be another one. I'm about to be speaking with Dr. Ralph Martens, who holds professorships at both Macquarie University and the University of Western Australia, where he is a professor of neurobiology and the foundation chair of aging and Alzheimer's disease, among other titles. He has been investigating Alzheimer's for decades now, including a great deal of looking into the relationship between testosterone and Alzheimer's, both of which are very well known in their own rights, but are probably not topics that go hand in hand in most people's memory banks. But by the time you've heard this interview, you'll understand why they might. Beyond his neuroscience work, Dr. Martens is also the co-author of an upcoming recipe book. This book isn't out yet, due in a couple of months, but it's called Maggie's Recipe for Life, going specifically into foods that one could eat to make Alzheimer's less of a likelihood in your personal future. We'll put up a pre-link to that where you could find that book in the show notes. Couple of terminology things I wanted to drop on you before the interview gets underway. There's a couple of references to JAMA, that is JAMA, the Journal of the American Medical Association. And PSA is not public service announcement, but prostate-specific antigen, a biomarker that offers clues as to your prostate cancer status. And by the way, fair warning, this interview is going to make you feel like getting at least some low-level exercise. So snap in the earbuds, take a walk, and here we go with Dr. Ralph Martens.
Jesse, I got involved in Alzheimer's disease now for over 30 years. It's actually 33 years. And the reason why I remember it so vividly is my second daughter was born a few days after I started working on Alzheimer's. And the reason why I got involved with Alzheimer's was because my father-in-law had been diagnosed with Alzheimer's in his 60s, early 60s, so it's fairly young. And I wanted to learn a bit about it. I already had a job lined up in New Zealand, but I just started working to understand the disease, and that's when it all started. And at that time, I joined the laboratory of Professor Colin Masters, who's now in Melbourne and a close collaborator of mine. He was and is a neuropathologist. And the only way Alzheimer's could be diagnosed was after someone died, you examined the brain and you looked for what we call amyloid deposits. And that was described by Dr. Alzheimer in 1907. It hadn't changed much till 1984. And what we did as a team then, and I was trained as a biochemist, was to extract these amyloid from the brain and try to identify what was the protein that was built up in these sticky plaques that build up in the brain. Because from my thinking, it was that if we could isolate and identify the protein, we then have something to target, basically the culprit that played a role in Alzheimer's. And this turned out to be a protein called BetaAmyloid. It's a small protein, smaller than insulin, but it's high, it's very sticky. So it tends to self-aggregate very readily. And this was the way that people were describing Alzheimer's disease. Now had this small molecule, and from there, people in the US and in Germany identified the gene that coded for it. And it was a gene that was present on chromosome 21. And how they got there was because we know that people who have Down syndrome, they have an extra copy of chromosome 21, show the same amyloid pathology that we see with Alzheimer's. So that helped narrow down which chromosome to focus on. And it was shown to be a much larger protein that when it got processed in an abnormal fashion, there was a lot more beta-amyloid being released. That's how the biology of the amyloid story came through. And to this day now, amyloid is the major target basically for trying to treat Alzheimer's. So that's how it all started. Unfortunately, as you know, and many of your listeners would know, there is no effective drug yet for Alzheimer's. The field has been moving very, very slowly. Our colleagues about 15 years ago showed that basically if you made a vaccine, so you injected beta-amyloid into mice, you were able to markedly reduce the amyloid in the brain, even when they were much older, and improve their memory. If you injected them much earlier when they're very young, and these are mice who have been genetically designed to get Alzheimer's, so they have a gene which has a mutation that causes Alzheimer's. Mm-hmm. You basically prevent the formation of amyloid altogether, so the brain is super clean. So that was very exciting then, and people then jumped from mice to men. We went a bit too fast, and unfortunately there was inflammation with the initial vaccine approaches. They then went to what we call passive immunization, and that's what's currently being used a lot now in targeting specific regions of the amyloid protein. And they had incremental benefits. They basically were not able to reduce the amyloid as effectively as we saw it in mice. We've now got it pretty effective now with a couple of the drugs that are out there. So they've got what we call the right dose. But the question is, are we going to improve cognition? And that hasn't quite happened yet. There's a hint that it's happening, but I think the bottom line is it's too little, too late. We've got to go in much earlier in the piece. And what the current approach is now, so there's a big trial called the A4 trial in the United States, and we have an arm here in Melbourne, where we're looking at people who've got preclinical Alzheimer's disease. And that's the work that my team and my colleagues in Melbourne and the CSIRO, which is the equivalent of the NIH, have been working together. So it's a big national initiative in Australia, where we've been following 1,100 people for the last almost 10 years now. And we've been examining their brain, taking pictures of their brain, so we can look at how much amyloid's in the brain, interrogating the blood, looking at lifestyle, the whole gambit. And that sort of study has identified people who are healthy controls, but their brain is full of amyloid. So we'd call them preclinical Alzheimer's. So it's known as the ABLE study, the Australian Imaging Biomarkers Lifestyle Study of Aging. And that study is a similar one in the United States called ADNI. So there are only two major studies around in the world that have demonstrated such exciting findings, that basically Alzheimer's disease starts at least 20 years before the onset of symptoms.
Wow.
And by that powerful technology of visualizing the brain during life, we're now be able to identify these very high-risk people. And these are the people we are hoping that now the drug will prevent the onset of clinical Alzheimer's disease. And so these trials are happening as you and I speak.
Has the technology progressed to the point where while a person is still alive, that there is a smoking gun that you can say this person definitively has Alzheimer's, or is it still something where it's a post-mortem analysis that gives the final thumbs up, thumbs down?
No, so it's reached that stage.
Okay.
So this is what we've been finding for the last 6-7 years. So it's known as a PET scan, a positron emission tomography scan, which uses an amyloid binding agent that's radioactively tagged and basically lights up the brain where the amyloid is. And it's been verified. It's very, very powerful evidence. The question now is, can we provide it to the community at large? And that's the hard part, because it's expensive. It costs about $3,000 roughly per scan. But it's definitely very powerful now for identifying these people to undertake clinical trials, that we hope are going to have a major difference. Now, this is where the testosterone story comes in. So that's targeting amyloid directly. And I guess I've tried to make the case to you that we think amyloid is the primary feature for Alzheimer's. It may not necessarily be the primary feature for vascular dementia and other types of dementia, but definitely in Alzheimer's, it is the initiating feature that then leads to other toxic action taking place. So if you take amyloid out, you effectively are treating Alzheimer's disease or preventing Alzheimer's disease. Now, during this period, I became interested in the hormone testosterone. And the reason why I became interested in testosterone was a very good friend of mine, Professor Sam Gandhi in the United States, was doing a lot of work on estrogen, so in women. Basically, he demonstrated, and his colleagues and collaborators, that when estrogen levels go down, and we see that very profoundly in menopause, you get a sharp rise in amyloid in the brain. And that's why estrogen therapies were being targeted, going back a good almost 18 years now. And unfortunately, for the people working on estrogen at the time, a study was done with much older people who had other comorbidities, and there were some negative impacts that was published in the journal JAMA that created a backlash in the community. And so people were hesitant to work on estrogen. But that story is not complete. There were many drawbacks in that particular study that is now well recognized. So many people in the community are still going back to getting estrogen replacement therapy, and it makes a benefit. It just depends how old one is and what type of hormones needed. But I was interested if estrogen is good for women, what does testosterone do? Can it do the same thing for men that estrogen does for women? And interestingly, testosterone gets converted to estrogen in the brain. So that's another interesting thing to bear in mind.
Yeah, that's an odd little tidbit.
So we got involved about now 15 years ago. We published an article in JAMA. And Professor Sam Gandhi was visiting Australia as a distinguished scientist, and I got him involved in the research. We were approached by people and by clinicians who were working on people with prostate cancer, and basically were told that the wives and the spouses had found that when they were treated for their prostate cancer, which is to bring their testosterone down, they were noting that there was subjective memory, there were memory complaints in the people, their mood was affected. And so we decided to look at what testosterone withdrawal was going to do to these men. And what we found quite strikingly was testosterone with the drugs that are used for prostate cancer can come down within a period of 3 to 4 weeks, hits rock bottom. And in that period of time, we saw a sharp rise of BetaAmyloid in the blood. And so that was the first clinical finding ever shown that bringing testosterone down raises your amyloid levels in the blood. We then went on to investigate in animals because we could do more interrogator studies where mice were castrated. We used guinea pigs in particular because they make the human form of amyloid. And again, we saw the same effect. In humans, there was chemical castration. Here, there was actual castration. And you saw a marked rise of amyloid, not only in the blood, which was what we showed with humans, but we were able to measure it in the brain. And it went up in the brain. So that demonstrated that low testosterone results in high amyloid buildup in the brain.
And pretty quickly, too, though. Is it within a matter of weeks that people were seeing those effects? Exactly.
And the same thing we were seeing with these guinea pigs. And if we gave them testosterone back, the amyloid levels markedly lowered. Clearly demonstrated that testosterone is playing this profound effect in lowering this toxic amyloid. And we did a number of other studies. We did association studies, and we've published all that, where people who have low testosterone, men, have high levels of amyloid. And more recently, in our large 1,100 cohort study, we looked at the men in those studies because now we had the ability to look at the brain. We had the ability to non-invasively look at amyloid in the brain. And we demonstrate now in humans that when your testosterone is low, the amyloid is elevated in the brain. So this basically made us interested in looking, can we do something with bringing amyloid down in the brain using testosterone? So all the approaches currently have been using antibody-based therapies, but testosterone we thought might be attractive. And we then progressed to look at, do a small pilot study. We did that in Indonesia because I had a neurosurgeon, Dr. Eka Vajapramano, who was doing his PhD with me, very busy surgeon. And so I designed the trial where he could undertake it at his hospital. So that's the reason why we did it there. And it was a fascinating experience. Very interestingly, there's a cultural response to testosterone. In Australia, if I wanted to do a clinical trial, I get hundreds and thousands of people want to be part of the study. There's something interesting about Australians wanting testosterone.
Right.
In Indonesia, we didn't get that response. It was a very hard slog getting just 46 people into a trial. It took 2 or 3 years to make that happen.
That's fascinating. What's the social stigma?
So they either feel they don't need it, and maybe they don't. Whereas in Australia, I think we need it or want it.
Yeah.
But it was quite intriguing. I still haven't got over it. But they played a major role in us getting the safety. We wanted to look at the safety because some people have made claims that testosterone will increase your PSA levels, puts you at high risk of prostate cancer, and that's how we started the study, our first initial human study. things to do with heart, cholesterol, factors may be elevated with testosterone. And we weren't giving them high testosterone. So I really want to stress that. It was to give them enough testosterone so their levels were within what you consider the optimal range for their age. And these were people who had mild memory complaints, and their memory scores were just at the borderline of being normal, slightly under.
Let me ask you a question quickly about beta-amyloid. Sure. Because this is something which is called a plaque, I think a lot of us, when we hear that term, we think of the plaque that builds up on your teeth if you don't brush your teeth often enough. Yes. And it almost makes you think that once it's sort of in your brain, it's going to stick there and isn't necessarily going to get cleaned out by any natural process. Obviously, we're not taking a toothbrush or anything like that to our brain.
Exactly.
Is this something that there is a natural way that this can be cleaned out, or is it kind of once it's there and it's only going to get worse?
So that's an excellent question, Jesse. For many, many decades, we all believed that the plaque was there to stay. Once it's there, you can't get rid of it. And our thinking changed dramatically about 15 odd years ago when a bunch of researchers in the US showed that if you vaccinate with beta-amyloid, later in the life of these animals, when they already have these plaques, you actually get a reduction in the plaque. So that was the first exciting finding, is that you can actually clear this amyloid. It's not there to stay. And since then, to answer your question, we're now getting a lot of evidence where certain factors in terms of our lifestyle can contribute to the clearance of it. Probably the most powerful effects has been with exercise. And if you look at exercise and Alzheimer's, the publication list has basically gone crazy. We've got hundreds of papers coming in the last few years, but exercise is having a profound effect on cognition. We've seen that in our own studies. One of my postdocs, Dr. Belinda Brown, has looked at the effects of people doing exercise, and these are healthy controls. And if they just increase the intensity of the exercise a bit, they get a benefit in their cognition. So that is fascinating. I strongly believe that exercise can play a big role in helping the body get rid of amyloid and clear it. Now, what is the mechanism of that? We still don't understand the mechanism. There are multiple mechanisms, but one of it is that we know that testosterone levels can get increased with exercise, and that maybe play a role. Interestingly, testosterone itself not only blocks the production of beta-amyloid, it also activates enzymes that break down beta-amyloid. So in effect, it helps clear the amyloid. So that's a fascinating thing. The other bodily function you were alluding to that we think is extremely important, that only got a lot more attention in recent years, has been sleep. So again, sleep deprivation results in massive buildup of amyloid. That was shown in animal models. We've now shown them in humans. And again, if you can improve sleep quality, and this is the work being done by another one of my top research scientists, Dr. Rainey Smith. She's now giving them, looking at people who have a problem with getting to sleep, latency in sleep, and they have increased amyloid in their brain. Improving their sleep quality is already showing quite significant impact on lowering the amyloid. So for sleep, we recognize it in simplistic terms is the body's garbage disposal system comes into action when you're having a good deep sleep and helps clear the amyloid and break it down and get rid of it. And now we're also seeing people with sleep apnea. They probably have the highest risk. So disrupted sleep due to sleep apnea now results in increased amyloid in the brain. And people are thinking, yes, that's part of the factor, but also the lack of not getting enough oxygen, becoming hypoxic, would also exacerbate the whole process.
Let me ask you to be a little bit prescriptive now. I'm curious, I'm sure other people will be too. Do we know anything about the types of exercise that might be most advantageous? For example, is it trying to hit a certain number of minutes of elevated heart rate per day, or is it the intensity that matters more than the duration?
So I'll give you an answer based on our limited understanding to date. That's where the biggest work is being undertaken, is to determine what dose of exercise do we need. How much, what intensity. So we don't have all those answers, but we do know enough that we can tell your listeners is that even walking for 30 minutes a day, a bit of a brisk walk, but even a gentle walk would be helpful, will benefit people. So, and that was the study that basically sparked all the research. It came from Perth in Western Australia, I think some 8 years ago, by Dr. Nicola Lautenschlager, with people who already had clinical Alzheimer's. Their rate of decline significantly decreased just by walking 30 minutes a day. Now, if you were to take that as a bit of a higher level, your benefits are going to be greater. And as I mentioned to you, one of my collaborators and my leading researchers working in exercise, Dr. Belinda Brown, showed that people who just had increased intensity of exercise, like jogging as opposed to walking, for example, their memory was sharper. These are normal people. These are people who don't have any memory problems.
Yeah.
So intensity is telling us, and so currently as we speak, she is conducting trials looking at different degrees of intensity to see which is the optimum one for people that age, people in their 60s and older. So that's going to be a factor. The other factor that is also being looked at is weight-bearing exercise, resistance exercise. And we think there's a combination that's going to be ideal because we know that insulin resistance, again, is a major risk factor for Alzheimer's. And when you get a buildup of insulin resistance, you get a buildup of insulin, which interestingly competes with beta-amyloid to be broken down. So basically, it's a much better competitor, and beta-amyloid starts accumulating. So really, the weight-bearing exercise helps you to become more insulin sensitive, and through that effect, impacts on beta-amyloid. So we definitely need both. We still haven't worked out how much of the resistance we need. Probably 15 minutes a day is what it looks like would be certainly beneficial, but the optimum dose, you'll have to watch the space. And I think this is where the whole field now is going. We want to get those magic drugs, terrific, but what can we do now for people? And lifestyle now is taking a big turn in terms of the impact it's having. And mainly from the fact that we know that what we do can impact on amyloid building up. One striking finding, and Dr. Belinda Brown was the first author on that, was we know, for example, that a gene known as ApoE4, it's associated with high cholesterol and heart disease for many years before it was linked to Alzheimer's in 1993. It accounts for 15% of the community. So 15% on average in the Caucasian community will have this gene. So it's called a genetic risk factor. It accounts for half the people who get Alzheimer's. So by far, it's the major genetic risk factor for Alzheimer's disease. And what Dr. Brown showed together with the rest of our team, people who had this particular gene and did not exercise, so were sedentary, their amyloid levels were elevated, putting them in basically preclinical Alzheimer's. If they increased their activity, the amyloid came down. So look at another subset. And if they had even more physical activity, it was back to normal. So this is probably the most striking message to me, is that if I have that gene, I definitely need to do exercise. There's no way out. People always use this term, you can't change your genes, but you can change the expression of those genes, especially when they're genetic risk factors. And this ApoE4 gene, this bad guy, can be modified considerably by how we behave. No, not just exercise. Diet is another big player to pay attention to, and obviously sleep.
Do we see any particularly strong correlations between things in a person's diet and whether they're likely to be building up beta amyloid in their brain?
Yes, we do. And again, because the technology has advanced and we can look at amyloid in the brain during life, that has allowed us to open that window and basically address that question. And as I mentioned to you, we had this major study called the Australian Imaging Biomarkers Lifestyle Study of Aging. We basically followed them for several years, looking at their dietary intake. And what we found very clearly was that those people who adhered very strongly to a Mediterranean pattern of eating had the lowest levels of amyloid in their brain. That's by far the strongest. And there's lots of other independent groups showing the Mediterranean diet is good for prevention of Alzheimer's, but this is the first piece of direct evidence to show that the amyloid levels in the brain are diminished. And this was done by Dr. Rennie Smith. That work hasn't been published yet, so you're hearing it before we're putting it out.
You heard it here first.
Exactly. And I'm actually now, the approach I've taken is you tell people to eat well, and doctors say that all the time, but they somehow don't get the message across, and it doesn't register. So I've done another little interesting experiment. I've collaborated with a very prominent chef here in Australia known as Maggie Beer. She's an Australian icon, loved by Australians. Basically, I've written about what's good for the brain. She's incorporated them into beautiful recipes. So the book comes out in October. It's called Maggie's Recipes for Life. It's a way of getting people into a lifestyle, but an enjoyable lifestyle that they stick to. It's not a diet book. It's basically a pattern of eating. So a lot of the factors I've talked about the Mediterranean diet, but we've also brought in spices. Interestingly, a number of spices are very potent anti-amyloid agents. I'm actually doing clinical trials to look at some of them. For example, turmeric, the curry spice, it's a very powerful antioxidant, anti-inflammatory agent.
Yeah.
Been implicated in cancer, but we are now testing it for the prevention of Alzheimer's. And we've got an ongoing trial going with that. But there are a number of other spices like that. And the bottom line in the Mediterranean diet is plant-based foods. We think they are the most powerful approach to targeting. And it's some of the basics we think about it. The fruit, for example, pomegranates. people recognize that fruits are good for you, but in pomegranate, there are a number of amazing ingredients that protect the brain. So there's a drug that's been developed that basically prevents the production of beta-amyloid. So it's called BACE1. There's an enzyme called BACE. It's a small term for the whole technical term, but it basically cuts and releases the amyloid. The inhibitor blocks the enzyme. In pomegranate juice, that particular inhibitor is present, so natural juices. But not only that, it has other interesting ingredients in there that play a role in longevity. And interesting enough, now we hear about the microbiome. So many of those compounds need to be broken down in the gut first. So you've got to have the right healthy microbiome to get the maximum benefit.
And a lot of these things, I mean, it's not like it tastes bad. You don't have to hold a gun to somebody's head to get them to enjoy pomegranates on a salad or something.
And if you know what it does for you, it'll motivate you to keep going. And then there are other agents. I mean, unfortunately, I was a late bloomer in appreciating plant-based foods. I love my meat pies, which is a typical thing in Australia. I tend to be more of a meat eater until very recently when I've gradually appreciated how powerful these whole foods are. I never knew, for example, that parsley is one of the most powerful anti-inflammatory agents you can have. And it blocks amyloid in the brain.
Yeah.
If you get it in the right doses. So it's having that knowledge, and that's what I try to bring out in the book. That knowledge then makes people more aware how potent these agents are if you have them the right way, and they're enjoyable to eat. It's not a medicine.
You mentioned earlier when we were talking about testosterone how one of the concerns that some people have with testosterone supplementation is around prostate cancer.
Exactly.
Can you talk a little about that relationship? This is sort of a naive thing for me to say, but part of me thinks if I had to choose between prostate cancer and Alzheimer's, I'd take prostate cancer hands down, but maybe that's the wrong attitude.
I know, and many people have said that to me, exactly what you said. When we showed this high change in testosterone, many of the urologists and people working in cancer got a bit upset with us when we published that in JAMA, because I guess it sort of then makes people concerned about getting Alzheimer's. And now, 20 years later, there were two major studies that were published in the United States from Stanford and I think the Mayo Clinic, where they followed 20,000 men who were treated for prostate cancer and found that their risk of Alzheimer's at least doubled as a result of bringing the testosterone down. So
wow.
I think we've been vindicated in terms of what we showed that long time period ago. So that is rather fascinating.
When you say doubled, I mean, doubled always sounds big, but sometimes when people say doubled, they're talking about doubling from 1% to 2%. What are the actual odds that any given person of a certain age, let's say 75, is going to be diagnosed with preclinical Alzheimer's?
Okay, so that's a good point. So aging is probably the biggest risk factor for Alzheimer's. And the statistics basically show, and it probably varies slightly between country to country, but it's on average in westernized country, if you're 60 to 65, it's about 5%. And every 5 years that doubles. So 75%, you're talking about 10 to 15% of older people at risk of Alzheimer's. And if you happen to now have your testosterone down, that would be doubled. So that's quite significant. And I guess it points to the fact that you're bringing the amyloid levels building up in your brain faster. You're enhancing that whole process. So that's what it points to. How do you deal with it is a good question. I think we need to be able to look at ways in which they can, for example, if they've had prostate cancer treatment, exercise is another way of bringing up your hormones in some form. But what I would like to show your listeners is testosterone does not cause prostate cancer if you don't have it. Mm-hmm. So I guess they need to be very clearly examined to make sure that they haven't got it before they go on it. But there have been big studies in the UK in particular where they show, where they've been monitoring them, and they're talking about thousands of people, and they show the incidence of prostate cancer in people taking testosterone and the wider community are less. And I guess mainly because they're so vigilant in making sure that they don't get people of high risk involved with taking it. And that was one of the questions we wanted to ask when we did our study. We did that for 6 months in these Indonesian men to see what happens to your PSA levels. And what we did find was, yes, in some of them, the PSA levels started to rise, but they were all within the normal boundaries. So they never went into the danger zone. And also, we need to be careful that we're not talking about taking a high dose of testosterone. I don't support that. We are looking at taking enough testosterone to get you within the normal levels of what it should be. The other concern with taking testosterone is that some men will make too many red blood cells. And so, again, if anybody was going to take testosterone, they need to be monitored regularly, every 6 to 8 weeks. It can be easily fixed because blood is withdrawn. There's just venesection done, but you still need to be able to monitor it and not just take it and take a testosterone preparation and then just don't do any monitoring whatsoever.
What actually happens there? What is the negative outcome from having too many red blood cells? That seems like it would be not such a bad thing, I guess, on the face of it.
Well, if you have a few more red blood cells, it's good. You have much more energy. It's terrific from that perspective. But if you have too many, and there are boundaries being set of what hematologists or doctors who specialize in the area say is safe, you can then put yourself at risk of a stroke. And so you don't want that
No.
in any form or fashion. So, but it's picked up much earlier. So if they would take testosterone at 6 weeks, they wouldn't be going super high, but it'd be clearly showing that they're high enough now for venesection to be taken. And it brings it down again.
At what age do you feel like people should start being specifically cognizant of their testosterone levels? You know, you mentioned that your father-in-law in his early 60s, he was diagnosed with Alzheimer's, and that subsequent evidence has shown that it starts 20 years before symptoms show up. So that would mean, I guess, for him, probably early 40s or even earlier, it was already starting to develop. At what point should people start looking at biomarkers and putting a careful eye there?
So I guess I got to just put a proviso there that testosterone is not the only feature to pay attention to. But in men, I would say from 40 years onwards, I mean, men tend to have, some men have much lower testosterone than others. So definitely that's when I would probably want to pay attention to my testosterone levels. Men are luckier than women. We have andropause where it tends to go down gradually, not as dramatically as in the menopause for estrogen. But nevertheless, in some men, it goes down much faster than others. And again, this is where lifestyle comes into it. So I think having a healthy lifestyle can make a difference to your testosterone levels. Men who are, for example, eat a bad diet and so develop a lot of fat around their midsection and also are sedentary. In these men, their testosterone, they may be making enough testosterone, but their testosterone gets broken down to estrogen, which is something they don't want. And because the fat cells make a lot of this enzyme called aromatase that basically breaks down the testosterone. So this is a clear example where lifestyle can impact on your testosterone levels. So a lot of men would be having that, and that can be easily fixable by changing their lifestyle.
And you've still got an ongoing study into testosterone. You have by no means hung up your testosterone spurs. Do you want to tell people what you're working on currently?
So obviously talking about testosterone, that's something I really wanted to do because, I think it can have a huge impact. And because it's not a commercially funded study, it's been harder to make happen. And I still haven't got all the funding I need for it because I need another $1 million more, but we've raised $3 million and we're kickstarting it now. And so we're asking the question, if it takes men who in their 60s who are clinically normal, so their memory is still very good, but they have amyloid in their brain. So the study will have only men who've got amyloid in their brain that would say they have got preclinical Alzheimer's. So we have to screen over 600 to get 200 into the study. And so we will be then giving them a testosterone implant. Some of them, we have healthy controls, obviously, with the placebo. Some of them are getting testosterone. And then we've got another arm where we want to see whether there is a benefit, and we're bringing another lifestyle approach. We found that omega-3, which we find in fish particularly, but not just fish, can have a profound effect that can complement the effects of amyloid, attacking amyloid in the brain. And so we're looking at a combination of that and see, do we get a synergistic effect? Can it bring the amyloid down? Can it improve their cognition? We're also doing what we call a CSF tap. So we're taking CSF, which is the fluid around the spine. And besides the amyloid imaging, that's the only other way where you can accurately determine that there's amyloid starting to build up in your brain. So it's a very strong biomarker of Alzheimer's disease, and see whether we can shift that too. So it's a 12-month study, and we're just about embarking on it. And we're doing it at 2 sites, in Sydney and in Perth. I have a joint appointment at Macquarie University and Either County University, but that's the aim of it. And I'm very excited about that, but we still need significantly more funding to take it all the way through. We had a lot of interest from women who also want to be part of it, but because of the nature of the funding, we focused on men first. But I'd like to do a study in women once we cut that corner, because there's a colleague of mine based in Melbourne who doing some very nice work, Dr. Sue Davis, on women to show that it improves cognition in women. And as you probably know, Jesse, the risk of Alzheimer's in women is even higher than that in men.
And also women tend to live a little bit longer, which probably just puts them at even higher risk.
In the past, people put it down to the fact that they lived longer, and that was the reason why the Alzheimer's was double in them compared to men. But now it's quite clear there are other factors. And I think there's a big drive, particularly in the United States, to really address this factor as to what puts these women in such high risk. I personally think estrogen plays a big role. I think estrogen going down so fast, we clearly see a very sharp rise in amyloid. And interestingly enough, a number of other diseases also become more prominent, such as heart disease and stroke for after menopause. So estrogen is protective, and it's long been recognized as a neuroprotective factor. And I think testosterone may be doing the same thing in the brain.
I remember one of the very first episodes of this podcast, the interviewee gave almost a throwaway line, but it's proven so true, and everybody I've talked with since that heart health is brain health. Basically, anything that you can do to improve your overall circulatory and heart health, it just goes in lockstep with the brain. There's nothing you can do that's going to be good for your heart that's going to be bad for your brain, it seems.
That's my mantra. Whenever I speak to the press, I always say what's good for your heart is good for your brain, and it can't be more true. The more we start learning about Alzheimer's. In the past, it was thought to be unique, the brain to the rest of the body, but it's not. Whatever happens in your periphery affects your brain. And now the vascular system is also playing a big factor. So beta-amyloid may be a major factor, but exactly like you said, your circulation, your lipid profile, which affects the heart, will impact on the brain. And very interestingly, and diabetes is another factor that is a very, very strong risk factor for Alzheimer's. And now Alzheimer's Association in Australia are starting to work much more closely with the Heart Foundation and with the Diabetes Association and foundations. Because, we want to have a basically an integrative approach. And if you can prevent diabetes effectively, you can reduce the risk of getting Alzheimer's. You're very right. There's a huge link. And I think the vascular component is only now starting to be seriously looked at in Alzheimer's.
Smart Drug Smarts.
So a very big thank you to Dr. Ralph Martens for taking the time for that conversation. Alzheimer's is one of those topics is sort of interest to everybody, even if it doesn't apply to you, which hopefully it does not in a direct sense. It's something which is so potentially important and so bad that we all need to be on the lookout for it. Obviously, this episode was a little bit more guy-specific rather than females. Both men and women have testosterone and estrogen, of course, but testosterone being what it is, this was sort of a guy-themed episode. Fear not, we're going to balance that out and consider this an IOU to all the female listeners. We do have an episode coming up for you, but probably some dietary advice there as far as the efficacy of the Mediterranean diet for warding off Alzheimer's that's useful to everybody, man, women, and child. And if you're curious about the Kickstarter campaign he mentioned for the Alzheimer's study that he talked about toward the end there, we'll put up the link to that at smartdrugsmarts.com/192. And now, as promised, a little bit of Alzheimer's avoidance nutrition advice in the Ruthless Listener Retention Gimmick.
Smart Drug Smarts, Ruthless Listener Retention Gimmick.
So Dr. Martin said a lot of positive things about the Mediterranean diet in that interview. And one of the staples of that diet, something that we think about as being particularly Mediterranean, is extra virgin olive oil. And according to brand new research published just about a month ago in the Annals of Clinical and Translational Neurology, there is fresh evidence that extra virgin olive oil not only keeps food from sticking to skillets, it also preserves memory and protects the brain against Alzheimer's disease. This research was conducted at the Lewis Katz School of Medicine at Temple University, where the senior investigator Domenico Pratico said, "We found that olive oil reduces brain inflammation, but most importantly, it activates a process known as autophagy. Autophagy, you may remember, means self-eating, which sounds kind of Hannibal Lecter-ish, but much less so at a cellular level. Brain cells from mice fed diets enriched with extra virgin olive oil had higher levels of autophagy and reduced levels of amyloid plaques and phosphorylated tau." Now, in that interview you just heard, we talked a lot about amyloid beta plaques. The other substance mentioned there, phosphorylated tau, is responsible for what are called neurofibrillary tangles, which are another major bad guy in the run-up to Alzheimer's disease and its memory symptoms. In order to investigate the relationship between extra virgin olive oil and dementia, Dr. Pratico and his colleagues used a mouse model known as the triple transgenic model. These mice develop three key characteristics of Alzheimer's. They have memory impairment, amyloid plaques, and the aforementioned neurofibrillary tangles. They divided the mice into three groups, and one group got an extra virgin olive oil enriched diet. The other mice just got normal mouse chow. The olive oil was introduced into the diet when the mice were 6 months old, which is earlier than Alzheimer's would begin to emerge in the animals. Time passed, and although the mice looked the same from the outside, they were tested at both 9 months and 12 months, so 3 and 6 months after the experimental group and the control groups diverged. And the group getting the olive oil enriched diet performed significantly better on tests of working memory, spatial memory, and learning abilities. The mice were sacrificed and their brain tissues were examined, and one thing that stood out immediately, the mice on the olive oil diet showed better synaptic integrity, apparently in large part because healthy levels of nerve cell autophagy were still going on, something which had been slowing down in the Alzheimer's mice in the control group, says Pratico. Thanks to the autophagy activation, memory and synaptic integrity were preserved, and the pathological effects in animals otherwise destined to develop Alzheimer's disease were significantly reduced. This is a very important discovery since we suspect that a reduction in autophagy marks the beginning of Alzheimer's disease. The next thing they want to do is basically to repeat the experiment, but push the timeline back so they don't introduce olive oil into the experimental group's diet until the 12-month mark, when the mice will have already developed amyloid beta plaques and the neurofibrillary tangles. This will be useful to see whether olive oil could potentially roll back the clock and be used in some way therapeutically. Usually, when a patient sees a doctor for suspected symptoms of dementia, the disease is already present. We want to know whether olive oil added at a later time point in the diet can stop or reverse the disease.
Just say no to scratch that. Say yes to the Smart Drug Smarts podcast. Join our mailing list at www.smartdrugsmarts.com.
Okay, so you heard it. That was it for episode number 192. Thank you for hanging around until the very end. If you enjoyed this episode, you will find all the links to everything that we spoke about here up online at smartdrugsmarts.com/192. If you missed last week's episode, I spoke with Dr. Mayank Mehta about how place cells let you find your way around in physical space, learn where you're at, and save that information for later return visits. And next week in 193, we're going to see if we can pull something out of the hat for left-handers. It's Left-Handers Day coming up soon. No promises there, but either way, we'll be back at you next Friday. Same time, same podcast, and with that same unflagging commitment to helping you fine-tune the performance of your own brain. Have a great week, and stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.